Hey folks, welcome back for another episode of Code Club. I am recording this video on, what day is it? January 22nd, which is 2 days after the inauguration of President Trump for his second term. With that is bringing a lot of anxiety to a number of people. And part of that is because of who he's bringing along with him this time around. And so one of those folks is Robert F. Kennedy Jr., who is kind of known for being a bit of a vaccine denier. And so the upshot within the New York Times, Francesca Paris specifically wrote an article about 2 weeks ago looking at child vaccination rates and what they've been doing over the past couple of years. And so immediately within this article, what struck me was this plot. And I thought this was really cool. Basically, what they're doing is looking at the share of U.S. kindergartners who are vaccinated against measles, polio, and whooping cough going back to 2011 and every year since then. What they found was that at about 2019, 2020, when the pandemic occurred, the rates of vaccination fell off. And there's probably many, many reasons for this. I know my own personal story. I've got a bunch of kids, and basically our clinic was closed, right? And that basically they didn't want anyone to come in unless there was like an emergency, right? So a lot of child care visit things weren't getting done, like vaccinations. And so you kind of forget about these things, right? And of course, they're not calling us saying, hey, get in here, you need to get your kids vaccinated. And so then kind of time elapses, and don't you know it, that eventually they basically fire you as a patient. And so then it's really hard to get back into the clinic with your kids. So it's complicated, right? But anyway, I thought this was an interesting figure. There were a number of things in it that I thought were really intriguing. One of the things I thought was cool was that they have a line plot with a point on each year to indicate that data was collected for that year. One of the things I think is cool about that is normally you might just have a filled circle on the line. But here what they have is they have a circle, and there's a bit of a margin on either side of the circle where the lines come out. How do you think they did that? Well, we'll figure that out later today. The other thing that I noticed is that they don't have a legend over here in the margin. Instead, they actually label the 3 different lines, which I think is a pretty cool look. In fact, in this other version of the figure I found, they actually have a line going up to measles to make it clear that this grayish measles goes with the grayish line. In typical New York Times fashion, they also don't have lines for the X or the Y axes. They then specify the Y-axis title as the title of the plot, the share of the U.S. kindergartners who vaccinated against, and then these 3 diseases, right? And then we see that it's a percentage. Another thing that I liked was that they have this line at 95%, indicating the federal measles target for vaccination at 95%. So this, I think, is a little bit deceiving. I don't know, but again, this is for measles, and we've got these 3 diseases, measles, polio, and whooping cough, right? And so is it safe to say 95% for all 3 of them? Again, I like that they had this line as an annotation that really tells the audience what are things supposed to be, right? Otherwise, this is just data floating out in the plotting window. But by having that line with that target label, it's much more clear what's going on. Going back then to the y-axis, some might think that this is also deceiving, right? Basically, we're looking at deviations from 95%, and that the y-axis, really the data varies between 92% and say 95%. That's 3%. Is that a lot? I don't know. This isn't really my area of expertise, but I'm going to trust them when they say this is a lot. And so one critique might be that, well, this should go down to 0, right? We often hear that. I often say that our y-axis should include 0. But that's mostly true with bar plots, and we can relax that a bit with line plots or scatter plots, where with the line plot, again, we're looking at relative trends and change in the data. If you really wanted it to have 0 on the y-axis, what you perhaps could do would be to look at deviation from the target, right? And so we could basically subtract all these numbers from 95% to see how we're doing relative to that 95% target. That when we would have the 0, and basically we would subtract 95 from all these numbers to then have values above 0 and values below 0, and most of the values would be below 0. Again, I'm going to make this plot, but if you want to make that with 0 on the y-axis, I would encourage you to give that a shot. Shoot me an email and let me know what you come up with. Finally, I noticed that they are using Libre Franklin, which is the sans serif font that we frequently see with the New York Times. And so this will give me another chance to try to use show text to incorporate that that free font from Google Fonts. Again, the version of the plot that I'm going to be building is this. It's very subtly different from what they had on the website. I think I may have gotten this from their newsletter. The main difference is that they have the whooping cough right up next to the right of the point, and the measles, they have a line, an angled line, going to the point. And so I think that, again, will add a little bit of challenge to making this legend that I look forward to doing with you. So the online version indicates the source at the bottom as being the Centers for Disease Control and Prevention. Wouldn't you know it, that when I go to the Centers for Disease Control and Prevention, you will find data for vaccination coverage and exemptions among kindergartners. There's more than just this one plot in the article. They also talk about exemptions, and they talk about things, rates of vaccination and exemptions by state, and what candidate those states voted for. There's a lot of really interesting stuff in there. And if you stick around the next episode, I'm going to try to build another one of those plots. But we've got to get through this one today. All right. So again, this page includes information about the data. It has any relevant footnotes, and then kind of information about the columns. I can download the data by doing export, and I want it to be a CSV. And so if you go ahead and click download, the file that we're going to get is the vaccination coverage and exemptions among kindergartners, 2025-01-18. Now, we want to make sure that when you've downloaded this file, that it's in the same directory as your R script, basically in your working directory. And so that's defined as this path here. Okay. So if you want to get this code, go down below in the description of this episode. You'll see a link to a blog post where you could get it. Also down there is a link to my weekly newsletter, where a week or two ago, I talked about this visual and at a 30,000 foot view, how I would take on regenerating this figure. And so we're going to go ahead and load the tidyverse. I'm also going to add this vector of vaccine names. These are the names that are in the CSV. And so if I do read_CSV on this, I will see that the data frame has a vaccine exemption, the dose, the geography type, the geography, the school year, the estimate, the population size, the percent surveyed, footnotes, number of exemptions, survey type. So I'm not interested in all of this information, but a good amount of it. And so what we'll do is we'll go ahead and pipe this then to a select, where I will select for vaccine exemption. And so again, that will get us that column. I could also call this vaccine equals that, and that then gets me that column, right? So what else do I want from this? I'm going to also want the school year. So we'll do school year equals, and so I've been using these backticks. I think I can also use ticks, like single apostrophes or double quotes, to do school year. Yep, that gets me that school year. Okay, so what else do I want here? And then I also will want the estimate, this value here, right? So I'll call that estimate equaling that. And this, again, needs to be in quotes. And maybe to make things consistent, I'll remove those backticks and put all of these column labels in double quotes. And so again, you need the quotes if your column name has a space in it, or I don't know, any kind of funky punctuation. I like to have lowercase, non-spaced variable names. And so if I need a space, I'll put an underscore like I have here for school year. Now we have the vaccine, the school year, and the estimate, but I can see already that there's information in the vaccine column I don't want, right? And so if I pipe this to distinct on vaccine, I see that there's a variety of vaccines as well as this exemption value, right? And so what I want are polio, DTP, DTaP, or DT, that's whooping cough, and then MMR, which is measles. But they also have varicella, which is chickenpox, hepatitis B, and then another MMR. But we'll roll with this one here. And so I'm going to get that by using my vaccines vector. So I can get that by doing a filter with vaccine %in% vaccine, right? And so this is confusing, but so I want vaccines, right? For the second one, I want it to be vaccines because I want it to be in this vector. So basically, if a value from the vaccine column is in this vector, I want it, right? And so now let's go ahead and pipe that to distinct. And there we see we have those 3 vaccines. That all looks good. I'm going to go ahead and remove this distinct statement. And now I see I've got 2,385 rows for the different values of vaccine, school year, and the estimate. And so this seems like a lot because I think there should be about 15 years, and we can test that, right? So let's go ahead and do distinct on school year. So there's 15 years and 3 vaccines. That's like 45, not 2,385. I think I also have state data in here on top of the national data. So let's go back and double check that we're not bringing stuff in that we don't want. And so sure enough, I missed this, that there's geography type, geography. So let's look at the different geography types that there are in here. And so I'm going to go ahead then and do a distinct on geography type and put that in quotes. So that's weird. Maybe this is a case where I need geography type to be in backticks. So there's states and national. Okay. So I think what I want is national. And so let's go ahead in here then and do filter geography type equals national. And then that needs to be in quotes. And so now what we've got is then geography says, I think, United States. So let's go ahead and double check. And by piping this to geography in place of geography type. And so then we've got United States and US median. So I want United States. All right. So we're getting this figured out. We'll take geography and we'll put that in our filter. And then here we're going to want United States as the value. And then let's remove this distinct statement. And so now we've got 143 rows. Again, that's all of the different diseases being vaccinated for, as well as exemptions, as well as the years. So let's put this all together now. And I still have this distinct on the end. So let's try that again. And so now I have 45, right? So the 15 years and the 3 diseases, 45. Great. One other thing I'm noticing just in this one view is that we have data here from 2010, 2011 being listed as NA. So the data in the plot goes back to 2011, 2012. And so this would be before then, right? And so let's go ahead and do a filter with vaccine equals MMR. And hopefully this will tell us what other years there are, right? And so if we arrange this by year, oh, it's not happy. Oh, that should be school year, not just year. All right. And so now we see that there's a 2009, 10, 2010, 11, right? And so it doesn't look like there's data, at least for MMR, for 2010 and 11, but our plot starts with 11 and 12. So why don't we go ahead then and remove those 2 years. So we'll get the cases where the vaccine is in vaccines and school year not equal to 2009, 2010, and school year not equal to 2010 to 11. And let's put this on a separate line so it doesn't go off the right side. All right. So I'm noticing I have 2009 to 10 here. And I wrote out the whole thing with an underscore. So I really missed that. So it's 2009-10. Again, it's got to be right on or it's just not going to do what you ask it to do. Now what we see is that we do start with the 2011-2012 school year and go out from there. And then we've got a total of 39 rows. So that's 13 years for each of the 3 diseases. I'll go ahead and call this CDC data. And now we've got that CDC data that we can use to plot. We'll go ahead and do ggplot AES. On the x-axis, we want the school year. On the y-axis, we want the estimate. So we'll do color equals vaccine, and then we'll do geom line and geom point. All right, so we've got the data there, but you'll notice we don't have the line, and that I'm getting a warning message about needing the group aesthetic. We'll go ahead and do group equals vaccine. And so now we have our nice connected lines. So we'll deal with the colors in a bit, but for right now, what I want to deal with is having that white border around our points. And what we're going to do is we're going to use my favorite plotting symbol, 21, that allows you to set the fill color as being distinct from the border color. And so the border color, we're going to set to be white. And so to do this, we're going to have the color be the vaccine and the fill be equal to vaccine. In geom point, we'll do shape equals 21. So that looks like what we had before, right? But now within geom_point, I can do color equals white. And so now what you see is that we have the white border around our points with the line. Very cool. Now we want to start working on the titles of our axes as well as the plot. So the y-axis in this version doesn't have estimate on the y-axis, whereas on the x-axis it has school year in all caps. So with that, we can do labs. We'll do x equals school year in all caps, y equals null, title equals, and we'll say share of US kindergartners vaccinated against. And then for the caption, I'll go ahead and grab this one from the web version. Here then we'll say caption equals that. Now that I've been modifying the text, why don't we go ahead and bring in our Franklin font. And so we'll do library show text, and then I'll do font, add Google, and we'll do Franklin in all capital F Franklin. And then the family is going to be Franklin. And then to load this, we need to do show text auto. This will get the show text font use to be initiated. So I didn't see this error message before as I was talking to you. It says, did you mean one of the following fonts, Libre Franklin? Yes, I meant Libre Franklin. So I'll do that. All right. Now everything is good. No warning messages or errors. And then we need to do show text opts, and we'll do DPI equals 300. And so that will match the resolution that I am printing things out to. ggsave prints things out to 300 DPI resolution for PNGs. So we'll go ahead and load that. And so now let's rerun everything. Now let's turn our attention to this X and Y axis to get that to look right, right? This is a bit of a jumbled mess, as is this going by every, I don't know what this is. This actually looks odd. I'm wondering if it's actually being represented as a character, right? Because we've got uneven spacing, like 93.1, 93.6. It's also showing all the values like it is down here, which makes me think that this is probably coming to us in a character font. So let's look at CDC data, and we see, yes, sure enough, estimate is in CHR. So we need to change that. And so I'll also get rid of this arranged school year because we don't need to sort that, but we can do mutate estimate equals as.numeric on estimate. So now we see a bit more rational labeling on the y-axis. So here again, as we see with many New York Times figures, the number is sitting on the grid line. And so in the past, what I have done with you all is to add this using annotate. And occasionally people will say, hey, Pat, I did it with HJust and VJust using the axis text, right? So that's what I want to do with you all to show you how I would do that here. All right. So, but we want the limit to go from say like 91 up to like, let's say 95.5. And so we'll come back up here and do scale Y continuous, and we'll do limits going from 91 to 95.5. Good. So we've got the 91 up to 95.5. We don't want the expand on the bottom here or on the top. So we'll go ahead and turn off the expand. So we'll do expand equals C 0,0. And again, that gets 91 down here at the bottom and 95.5 up there. Good. And now what we want to do is go ahead and let's make the background cleaned up. Let's try like theme BW. So theme BW. So this gets us grid lines, but also gets us a border. I think I might roll with theme classic instead as my starting point for working with this data. So we'll go ahead and remove now the axis line and the ticks. Maybe we should have just stuck with the default theme, but hey, what do you know? So we'll go ahead and do theme, and we'll do axis.line equals element blank, axis.ticks.y equals element blank. And so then that gets rid of those lines. There are tick marks on the bottom, so I'm going to leave that there for now. But we need to go ahead and add in the grid lines. And so I'll put that up here at the top. We'll do panel.grid.major.y equals element line. Good. That gets us nice gray grid lines going across there. I don't want to mess with the size and thickness of things just yet. We'll get there eventually. So now we want to move these numbers up and to the right. And so what we'll do is axis.text.y equals element text. So if I do vjust equals 0, that moves things so that basically the bottom is right at the level of the grid line. If I did vjust equals 1, that puts it so that the top is right at that line. So what I'm going to do is a negative value. So if I do negative 0.5, then that moves things up, right? And so that might be a little bit too high. Maybe let's bring it down a little bit to say like 0.3. And so now we can see that our number, it's to the left, right? Sure. But vertically positioned, it's in the right spot. And now we need to move it over to the right. And so to do that, we can do the margin, right? And so we can do margin equals margin. R, I want my right margin, let's do minus 10. And so we now see that it's moving over to the right to rest on that line. So very cool. And so let's make it say minus 15. And again, we're going to be messing with things a fair bit. So let's leave that there for now. I am noticing though that the points from the line are falling kind of in the scope of that 95. Also, I notice I need a percent on that 95%. Let's go ahead and put the percent on first. And so what we can do then is back up here with scale y continuous. I'm going to do breaks. So we'll do 91:95. Again, that is a vector of all the values from 91 to 95. And then we want labels. And I'm going to do this in two parts. We'll do 91:94. And then we'll do 95 with a percent sign. And again, what this will get us is a character vector then of the values from 91 to 95 with that 95 having a percent on it. And so now we see, sure enough, we have that percent. I'm noticing that my labels are right justified. So I need to add an hjust of 0 to get things to be left justified. So now we see that our numbers are no longer on the line. So let's move it over a bit more. And so let's maybe make this 20. And that's pretty good for now. But of course, our data now is falling into our label. And I think the way we'll deal with that is by modifying our x-axis, which is exactly what we're going to do right now. So let's worry about our x-axis. And these labels are character types where we've got like the 2011-12, right? And so I think what I'll do is I'm going to redo that label to make this basically 2011, 15, 19, 23, but then give it different labels, right? And that way, by making this like 2011, I can make my limit, say, go back to like 2010 and maybe up a little bit to say like 2023.25, right? To get kind of that padding on either end, or maybe the expand will take care of that. But for right now, I certainly see that I need more expand on this left side. Let's do that with scale x continuous. And we're going to want limits to be 2011. Actually, I need to put this in a vector, 2011 to 2023. But I'm realizing that, again, my x aesthetic is a character. And so I'm going to modify this to make a year. And so we'll modify school year then with a str replace. And we'll do that with school year. And then the pattern we want to match is an underscore with 2 digits. I'm lazy, so I'm just going to put 2 periods that will match the 2 digits. And then we're going to replace those with nothing. And then if I look at CDC data, I see that I have, I still have the same year because I put an underscore again rather than a hyphen. Let's try that again. And so now we see that we have the year, but it's a character. And so let's go ahead and wrap this within an as.numeric. And it's complaining because I went too far in hitting my command enter. So let's look at CDC data. And now we see that year is a double. And so now back up here, I'm going to put year as my X aesthetic. And so now I see that I have years across the x-axis. Although it's 2015 and 2020, it seems a little bit odd. Let's come back up to our scale x continuous. That's our limits. Let's add our breaks. And so we want 2011, 15, 19, and 23. So we'll do 2011, 2015, 2019, 2023. That gets us our years. Of course, our 2011 is too far to the left. So let's decrease the limit and maybe let's try 2010. And I think that looks a lot better, right? So now you can hopefully see that there's more space, but that our number is still sitting on the grid line. Now what I want to do is fix the label to get the right school year, not just the calendar year, right? And so now what we'll do is labels, and I'm going to copy this down and put these all in quotes. 11 to 12, 15 to 16, 19 to 20, 23 to 24. And so there we now have our school years formatted very much in the same way that they had it in this version of the plot. Cool. All right, again, there's a lot of formatting we'll still need to do, but we'll get there eventually. One thing we forgot to do is to tell it to use our Franklin font. So within theme, I can then do text equals element text family equals Franklin. And so now we have our Franklin font. And I think this does actually look different than what we had before and more in line with what we have with the New York Times version. So another way that I know that the font changed was because I'm no longer correctly aligned on the y-axis. So let's go ahead and bump that over. Let's try 25. All right, so I do want to get rid of this legend, but before I do that, I need to change the color. So let's come back in here and we'll go ahead and do scale color manual. And then we're going to have breaks. And this is also where having that vector defined will come in really handy because these are the breaks. And so we'll go ahead and copy that down. And then our values are going to be the colors. So the first color to match is the whooping cough. And so I'll go ahead and put my cursor in there with my digital color meter, copy that, and then plop that in there. That's that yellow. And then I want to match the measles. So we'll get that cursor in that point. Paste that in, and then polio is this brownish color. So we'll go ahead and get that, paste that in, and add that in. And now we see that our colors match. But of course, we also set the fill, right? And so let's see, we had scale color manual, and we're going to want to also have that be scale fill manual. So now our plotting symbols color matches the line color, and that is good. We can get rid of that legend. And we can do that with geom_line. We can do show.legend equals false. And we'll also put that show.legend equals false within geom_point. And so this is starting to look a lot like what the New York Times has. We need to go ahead and thicken our lines as well as those plotting symbols. And so we can do that back up here with geom_line. I'll do line width equals 2. Okay, that's too thick. Maybe we'll go ahead and make it 1. And I think that looks pretty good. Now we want our symbol to be a little bit larger than the line. So here then we'll do size equals, what happens if we do 2? That's a little bit small still. Why don't we go ahead and up it to 3? So I think that looks pretty good. Again, things are going to move left to right because we're going to put some stuff in the margin here in a bit. But before I do that, I want to go ahead and put in this federal measles target. And we'll get the solid black line using geom_line. So we'll do geom_line. And if I look at theirs, their line goes behind the data. And so to get that, I need to call geom_line before I call geom_line. And we'll do y-intercept equals 95. The color equals black. And so we get that line. I think that's about the same thickness. That's very good. And now we need to add the federal measles target text. And I'm going to do that with an annotate function. And so go ahead and do annotate. And on the x-axis, that's going to be at 23. So we'll do 2023. Y, let's go ahead and make it 95. And then our label will be federal \n measles target. And it's upset with me for not having a geom, and that's because it should be geom equals text. All right. And so let's go ahead and put these aesthetics on the next line. All right, I think we're gaining on it, but I think what's happening is that it's centering it rather than right justifying it. So let's go ahead and right justify, and we'll do hjust equals what? 0, 0.5, or 1? 1, right? Because that's a right justify. So I have it at 2023, right? But our line goes to the right of that a bit. And I think that's because I have expand on. I think I want to go ahead and remove the expand from the x-axis. We'll do expand equals c 0, 0. The more I do these videos, the more I find myself using expand equals c 0 or expand equals false in chord Cartesian. I'm starting to think that I like having that control over the bordering of my data. I don't know. but that's just been my experience in doing a lot of these. So that works well for justifying the line, but I'm kind of losing some of the points over here on the right. And so why don't I make my scale x continuous limit? Let's go up to 2023.25, and I think that looks pretty good. We want this to be up and over then, and so I think my annotate, I can make 2023.25, and so our h just and then our v just should be what? I think it's 1 to get it to be moved up. Oh, nope, it was 0. Just kidding, just kidding. See, I forget these things, but it's easy enough to experiment with, right? Now that moves it up, but of course it's right underneath it. And so maybe what we'd want would be a negative vjust. So let's do like negative 0.1. That moves it up, but these lines seem kind of separated from each other, whereas this, they're a lot closer. And we've seen that we can modify that with line height within a geom text, right? And so we can go here and do line height. And let's do 1. So that brings it down a bit. Maybe we can make it a little bit smaller. And we could do, say, 0.8. And I think that looks pretty good. Let's move it up off the line a bit. And so we had negative 0.1. Let's go ahead and make it negative 0.3. So the next thing that we want to do is go ahead and put a right-hand margin in here for the plot so we can put in the names of the 3 vaccines. And so back here in theme, I think what I'll do is plot.margin equals margin. And on the right, let's go ahead and put like 40 and see what that gets us. And so that makes 0 all the way around except for 40. So let's go ahead and do t equals 3, r equals, let's go ahead and up that to like 60, b equals 3, and then l equals 3. And so that gives us a fair amount of room over here on the right. We might need more than that here in a bit, but let's see where we're currently looking. Yeah, I think we want to move things over a little bit more. So let's go ahead and make that, say, 80. So now what we want to do is go ahead and put the names in to the right of those points. And because I'm going to be plotting data outside of the plotting window, at least on the x-axis, I need to define some of my chord x continuous stuff inside of chord Cartesian. So let's go ahead and do chord Cartesian, and we'll do xlim equals, and it's going to be this stuff here. And so I can get rid of limits. Also, I have expand in both of these scales, so I'm going to go ahead and remove that from both of these. And then down here, I'll do expand equals false. Nothing has changed. And so now we should be safe to go ahead and throw in those names of those vaccines. I'm going to do it with another annotate. So we'll do annotate geom equals text. And then on the x-axis, we're going to put that, let's do at 2023.5, which should be to the right of the x limit. And then on the y-axis, we're going to want, well, let's actually take CDC data. Maybe we can make a data frame to do this for us. So we can do CDC data, filter year equals 2023. That gets us these 3 diseases, and these are our estimates. I think we can clean this up by piping this state to a mutate. Year equals year plus 0.5. And as I'm doing this, I'm thinking, I'm going to have to do a lot of futzing with this that I just don't want to do. So why don't we make a CDC label tibble, and we'll do a tribble, and we're going to want the label and the year and then the estimate. Yeah, I think that'll just be easier because I'm basically going to end up wanting to customize everything we've got. We'll go ahead and call this first one whooping cough. And so we'll go ahead and put a \n on that. And then the year will be 2023.5. And then the estimate, I'll start with 92.3. We might have to move that before it's all said and done. And then we'll do measles. And then that's also going to be 2023.5. And then that is this 92.7 polio and 2023.5. And that then is going to be 92.6. And so again, we have CDC label. Nice. And so then instead of this annotate, I'm going to go ahead and remove that. We'll do geom text with data equals CDC label. We'll do mapping. X equals year. Y equals estimate. And I'm noticing that year I put to 2024. point, and that's, I think, rounding that it's doing. I think it really is 2023.5 because that's what I've defined it as here. All right. And so then our color, we're also going to want to be based on the disease name, not the label, right? And so I'll then say vaccine, and then our label is going to be label. And so I need to add to my tibble the vaccine name, right? I'll go ahead and grab these names so it's easy to copy and paste. And so then I will take this for the whooping cough. I can just type it quicker, probably MMR. And then down here, we'll do polio. And then up here, we'll do vaccine. I'll get rid of this stuff. And so now if we look at CDC label, we've got all that. Cool. I'm wondering if I need to tell it to not inherit the AES, but I think it looks okay. I'm using year, estimate, and vaccine and label, which is basically what it used up here. I guess I don't have a group, but that's vaccine. So I have a vaccine column. I think we should be good. And so let's go ahead and tidy this up a bit. Nope, it's not happy. Because why aren't you happy? Geom text, mapping. Oh, it should be mapping equals AES, all that stuff, right? All right, very good. Now we have a legend back and we have our data being centered, but not shown outside the plot. And that's because I forgot to add clip equals off. So let's come back up to our geom text. And at this point, I probably could have just done the legend.position equals none in the theme, but what do you know? We're doing show.legend equals false in all of these geoms. All right, so that'll get rid of the legend. And then if we come to chord Cartesian, we could add clip equals off. And so that should show us the data outside of the plotting window. We now have our data shown and it's being shown outside of the plotting window. Wonderful. We want to left justify that rather than center justify it. So again, we come back up to geom text. We do hjust equals 0. And so now it is left justified. I'm noticing that theirs is a bit closer than mine. So why don't we go ahead and decrease that? I had 2023.5. Let's go ahead and make it 0.3 and see what that gets us. And that brings it over pretty nice. This whooping cough has a bit of spacing between it. So I'm gonna go ahead and drop that down and we'll do line height equals 0.8. And so that brings it together pretty nice. Before I go too much further with this, I wanna make sure I'm using the right font and the right size. I'm pretty sure that I am not using Franklin. You'll notice their G is kind of stylized differently than my G in cough. And so that is because when you're changing the font family, that is an aesthetic, right? And so any aesthetics are going to be controlled differently than what's in theme, right? And so if I come down to geom text, and here then I can do family equals Franklin. And so now you'll see I have that stylized G. This needs to be bolded. So we'll do face equals bold. And it's not liking face, it needs to be font face. I always forget that in geom text, it's font face. In element text within theme, it's face. All right, so now that's bolded. Theirs is a bit bigger font than mine. Let's see if we can put these next to each other. So let's go ahead and see now if we can increase the font to match the font size, and then we'll play with the vertical positioning. All right, so again, back up here with geom text. Let's get some space here. We'll do size equals 10, and then size.unit equals pt. So that didn't do anything for us. Let's go ahead and up that a bit. Let's go ahead and try 14. And so that's pretty nice. That might be a little bit too big. Let's go ahead and drop it to say 13. And I think that's pretty good. Now we can play with the vertical positioning of these. I'm noticing as I look at theirs, that theirs is right on the x-axis limit, whereas mine is over just a smidge, right? I'm at, what did I put it at? I think at 23.3 instead of 0.25, which is what the X limit was. So we'll go ahead and modify that. And then whooping cough, we know we need to move down a bit. And so let's go ahead and try 0.1. And that went down too far. Let's maybe put it up to like 0.15. And that looks pretty comparable to what they have here. Polio, again, we said was good. And then measles needs to be on the top of this grid line. So 93.2. Okay, that's too high. Let's bring it down to maybe 0.1. And I think that is bang on, good. Now what we need is the line to connect measles with the point. And so I'm going to do this with annotate using geom segment. And so we'll come back up here, and I'm going to probably want the line to fall behind the point. And so I will put that before geom point. So do annotate, and then we'll do geom equals segment. And so we're going to need x, 2 values for x because we have 2 lines, and then 2 values for x end, and then y and y end. Okay, get that in. Okay, so x is going to start at 2023.25, and then I'm going to have it go over to 2023, right? Because 2023 is the actual year that it's on, right? And so it's going to be a line that moves over, and then the y is going to be what is the value for MMR. So it's going to be 93.1, right? So 93.1 and 93.1. Now we see we have the measles line coming out of measles, going to the left. Maybe we want a little bit of space there, and so we can adjust that a smidge. Let's go ahead and make it 0.2, and I think that gives us some nice spacing. And now we need to bring it down to the measles point. And so we'll now add back to these vectors, right? And so the second line is going to pick up at 2023, and it's also going to end at 2023 because it's a vertical line, right? And then the y is going to start at 93.1, and then it's going to end at the value from MMR, which here I have as 93.1, but that's not right, right? So what was it? So CDC label, or CDC data, filter year equals 2023. That was 92.7. Okay. We'll go ahead and insert 92.7 for that second y end value. So there we go. We now have our angled line to match their angled line. I'm pretty happy with the way that looks. What do you think? Cool. All right. Now what we need to do is play with the sizing of things to make it match better what is going on in the original. Let's go ahead and turn our attention to the title and the caption. Of course, theirs doesn't have the caption, but we'll go ahead and do it with ours. So we'll do plot.title equals element text face equals bold. And so that gets us our bold face. It could probably be a little bit bigger and moved down a little bit. I think that is a problem with our plot margin. So maybe we should make the top 10. And then here we'll make our size equal to, let's say 12. So that moves ours down, but it's not big enough. So let's go ahead and up that to 16. And I think that's a good size font. Maybe we've moved it down too far now. Let's go ahead and make the top 8. And the left can be a little bit larger. And so we've got it 3. Let's go ahead and make that 8 as well. Nice. All right, so I like the title formatting. That's great. Thinking about this title on the 95% limit. So we had an annotate in here with this label. So let's go ahead and add family equals Franklin. And so that looks closer to what they had. And I think it's pretty close to the same size. I'm happy with the way that looks. So I'm noticing we have a bit of extra space to the right of our labels here. Let's go ahead and drop that down to say 70. And I think that's pretty good. Now let's kind of keep going clockwise here and go to the caption. And so the caption, we'll do plot.caption equals element text, face equals bold, color equals, let's do a gray, like 70 or 60. Let's do 60, that's cool. And we also want this to be H justified to the left, so be left justified. So we'll do H just equals 0, and that moves it over to the left, which looks pretty nice. And of course, we don't have it on this version that I'm sharing with you. The next thing that I want to do is think about our axis text, right? The size looks pretty similar to what we have for our vaccine names here. And so if I remind myself what that was size 13. So what happens if we come down here and do size equals 13? Oh, and that was the Y, not the X. So anyway, while we're there, theirs is a little bit smaller than mine. So maybe we could take it down. Let's try 12, and it's probably in between. And because I can't help myself, let's do 12.5. All right, so now we need to do it for the x-axis, which is what we were hoping to do. All right, so now what we need to do is do axis.text.x equals element text. And then we'll do size equals Go away pop-up 12.5. Pretty bang-on sizes, and that looks pretty good. And our school year, I think, is a pretty good size. They have a bit more margin between the title and the data. And so we can come back up to plot title and do margin equals margin B. Let's do 15. And it's not happy with me for some reason. I forgot a comma here after the 16. So we can probably bring ours down a little bit more. Let's say drop it down to 20. And we'll bring it down to, say, 25. I'll call that good. So there is a space I'm noticing in theirs between the top of the tick and the grid line, which tells me that our Y limit needs to come down a little bit from 91. And so if we come back to scale Y continuous, let's go ahead and make this a 90.8. And that's perhaps too much of a space. So let's go ahead and make it 90.9. That's good. And then our tick needs to be a bit longer and probably thinner than it currently is. So we need to do axis.ticks.x.length or length.x. We'll do unit, and let's go ahead and do 10 pt. And so this is mine again, which is way too long. Let's go ahead and drop that to, say, 5. So it could probably be 6, and it needs to be thinner. So let's go ahead and make this 6. And then we'll do axis.ticks.x element line, and we'll do line width equals 0.25. And so I think that's a nice thin tick mark that does a pretty good job of matching theirs. And now that I see it at 6, it could probably go back to 5. All right, so we'll just do that and call it good. And then above our axis text X, we need a bit of space because you'll notice there's space here between their label and the tick. And so we'll go ahead in here then and do margin equals margin. And the top, let's go ahead and put in 5. So there's a bit of space there. Maybe we could put more space on the bottom to separate it from the x-axis title, because I notice the x-axis title has a bit of space as well. And so we can then do, say, b equals 10. So I think that's pretty good. One difference that we have that they don't have, which is, I think, moving ours up a bit, is that we do have that caption in the lower left corner. Now, I notice our y-axis labels are off to the left side. So we need to bring those back to the right a smidge. And so then again, that was our axis text y, and we were using minus 25. Let's go ahead and make this minus 30. But now our data are colliding with our label. And so the way we resolved that was back up here in scale x continuous, where we're actually in our chord Cartesian now, right? Where we did 2010. Let's go ahead and drop this to 2009. And that maybe be too far to the right. Let's go ahead and make it 2009.5. And then I think that looks pretty bang on. Here we go. We have my version in the upper left corner. We have the New York Times version in the bottom right corner. I'm really pleased with the appearance of my figure relative to theirs. Let me know what you think. I don't think you'd be able to tell the difference if you had to pick one over the other. There are subtle differences that I'm noticing using the Google fonts is that mine, or the Google Fonts versions that I'm getting with show text, appear to be a bit wider than theirs, right? Like, so like Federal Measles Target, for something that's like similar in height, mine is taking up more space left and right. I don't know what that's about. I don't really care. But again, I think this all looks really good, and I'm really happy with the way this turned out. If you want to see the code that I've developed, again, down below in the description for today's episode, you will find all the code that I just generated with you, and I encourage you to get it and play with it. So as I mentioned, this article that came from the New York Times has a lot of great figures in it. The figure that I'm going to work on with you all in the next episode is this one that I can barely fit on my screen, that looks at the change in kindergarten measles vaccination rates between 2023 and 24, which was the past academic year, as well as pre-pandemic. And so I'm a sucker for paired data and kind of showing things with arrows like this. And so we're going to take this on in the next episode so that you don't miss my development of this figure in that episode. Please make sure you've subscribed to the channel and you've told your friends about what we're doing. And I'll see you next time for another episode of Code Club.